ARC have a new arena, or more accurately, new dividers for the old arena. This means that gone are the two long, thin antweight arenas that we were fighting in before, and now the arena gets split up into 4 separate square antweight arenas, of which 2 are basically used at a time, because running 4 fights is a lot. But now I want to throw someone over top of these. Hello everybody, I am Ben from Team Panic. This is not really a new goal. I really wanted to tabletop people in the old arena. This new wall system just seems like it might make my life a little bit easier. It's also not an original idea, and shout out to Angry Angie for beating me to the punch on this in their very first event out. I mean, they did do it with a very big vertical spinner, which does make things a little bit easier in this regard, but I want to do it with a lifter mechanism. But at this point, I have no design at all, so we are going to sit down and do the design together. I will also say this is not a CAD tutorial. This is me talking through my process and how I do things. The CAD process that I use, especially for antweights, is fairly antiquated. The software I use you cannot get anymore. This is not a tutorial. This is just a mind dump for me to you. So getting started, I don't start in CAD software, I start with a design idea. But that's not good for a visual medium, so instead I have busted out, run for it, my current flipper, and also a whiteboard. The robot is literally just here to show you exactly how big this new divider is in comparison to an antweight. As you can see, this is a fairly low antweight, so it's probably about double the size of most, which means that a lot of the design considerations disappear fairly quickly. Because of course, doing this, trying to get something over a high wall, our kind of options for this are a front hinge flipper, fairly standard conventional front hinge flipper. We've also got a forklift, much like free shipping from original Seasons of BattleBots, or we've got Mammoth, which is the spinner lifter, which is a bit of an odd robot to try and do a design for very quickly with stick figure kind of a logic. So where we're at already with this design is I have basically cancelled out the free shipping idea and also the original kind of back hinge flipper idea, because to try and get a back hinge flipper to get up this high is going to be difficult. That is a lot of space to cover. The forklift so we're cancelling this guy out. The forklift I am cancelling out as well, because very recently we've messed around with a forklift setup here, or a 4-bar lifter that kind of emulates a forklift setup here on the channel, and I wasn't too happy with that. Once you put a robot on here, which this is a very poor robot, there you go, it's a drum spinner, the whole robot tends to tip forwards and you lose traction on the back wheel and stuff. Like, that's just awkward and not very fun at all. So the final idea is Mammoth, or Mini Mammoth, which is just a fun thing to say realistically. And I think that we can do this inside weight, because the whole idea of Mammoth is getting as big as possible inside a weight category. That's exactly what we need to get over a high bar. So here we are in the CAD software that I use. This is 123D Design by Autodesk. It is a piece of software that they have stopped supporting. So as mentioned, this is not a tutorial on this. It is literally just a thing that I personally use because I've used it for a while, and it kind of meshes with how my brain does CAD. So this is, like I said, 123D Design. It's fairly similar to Tinkercad if you've ever used Tinkercad. However, it is just that little bit more powerful. And this is what I use primarily for kind of bashing a design out really quickly. Every robot I've ever designed comes from this software, at least in concept, and then a lot of the stuff like beta weights and up go into Fusion 360 and I CAD those out properly, but the initial idea forms here because I find it very easy to get the ball rolling here in 123D Design. The other thing you can see is that I use the software because I've used it a lot, and I already have N20s and motor mounts and everything CAD'd up and in the software ready to go. My first step here is actually going to be to add wheels, because for whatever reason this import didn't actually add the wheels that I'm using. So we're just going to do this. Anyway, that is our wheels and our motors. This whole setup is going to change very soon. And that is because what we're going to do now is actually get the stage set. The most important thing for me, as I said, this is a very kind of visual medium for me to do this in. So what I want to get done is to measure out all of the elements of the actual barricade itself, and also measure out run for it so that I know the dimensions that I'm going to be working with in this CAD. So this gives us our imposing wall that we now need to build everything around. Run for it is going in mostly because I want this robot to be big. I want it to be encompassing. I want it to be a dustpan style, and I want it to be able to grab hold of things, force them into the wall, and then use the spinner to slowly eke them over the edge and down the other side, which would be really, really cool. We've got our wheels in place. We've got our run for it. We've got our wall. We've got most of the things that we need to get started, especially as we've got motors ready to go. So I'm going to cut these in half, and this will give me 2 separate motor mounts that we can use, and then we can start by, actually what we should do is create a center section for run for it, because if we create a center section for run for it, we can have everything move based on the center of run for it. Push that face all the way out, and then we can actually work out how far off the midsection we are. We are 11 mils off. Okay, that's good to know. We're going to do this, move this in 11 mils. There we go. So I'm actually going to have a really wide wheelbase for this. I think I want to go, yeah, that'll do. So that's going to give us a wider wheelbase than run for it, which is going to be interesting. Select all of those, mirror it across there, bam, other side done. The only thing I will say is that this is actually currently under the canvas, so we need to correct for that. Now we've got a floor reference, a wall reference, and a run for it reference. So we've got everything fairly well correctly referenced and ready to go. And you can see that the wheel here is clipping through the floor, so we need to correct for that by moving this whole thing up and then dropping it exactly however far we need, which is 1.5 mil. Cool, so that is done. We're actually going to hide our ground reference for now because it doesn't really matter other than for that one thing. Well, at least, yeah, we can get it back in just half a second, but it's just going to make like selecting everything a lot easier so I can mirror things really quickly, and bam, there we go. As mentioned, this is going to be Mammoth, and what I want to do with this is I want to run a very similar arrangement to their anti-horizontal setup. Fun little editing note here as I kind of go through and finish this video up. I misremembered the Mammoth anti-horizontal wedges that it had. This is the only fight that I could see them in, which is the Mammoth versus Gemini fight from the season I was actually on Gemini. I'm not driving currently, I'm actually over here behind the pulverizer buttons, which is fun. But I remembered that these anti-horizontal wedges were actually quite a lot steeper than this, almost horizontal. Like I imagine them being at like a, I don't know, a 70-degree angle or something, not anything like this. I also imagined them, or remembered them, coming out past the wheels a lot more. I think I've got this weird false memory of a fight that happened not in this season, but in the 2020-2021 season that just doesn't exist, apparently. So we're going to be replicating a Mammoth that doesn't exist, because I'm kind of taking this idea and changing it and adapting it, adding in some elements from the new Mammoth designs as well. So that's actually what we're going to focus on. But I think the next thing actually is going to be to put in a simulation of the spinner. We're not going to get too technical or complicated with it at this stage, as literally all we've got is wheels, but we are going to actually put in a spinner of some form. And in this case, this thing needs to have a radius of 70 mil. In actual fact, it needs to have a radius of 75 mil, because what that means is the radius is the height of the wall. You can see, compared to the wall, this thing is huge, so this is going to be an enormous spinner. Cool, so our weapon is now centered over our wheels, which is going to be important because it means a lot of the mass of the robot is going to be centered over those wheels, which avoids a lot of the issues we've had in other robots in the past, including Annie, Are You Okay? And others. So the next thing to do is going to be to work out how we attach these motors up to a central axis, which we're going to put in our current favorite thing, which is 5mm diameter, 5mm radius aluminium tube is going to be what we're going to use for the axle. So that's going to be our axle through the middle of our spinner, because it doesn't need to go far, so it can just run on the actual aluminium itself. So I'm going to put in a much longer axle than I need. The next trick, as I mentioned, is to get these uprights and supports done, and we're going to do these in carbon fiber. I just need to kind of work out just where I want to put the electronics, because of course the electronics need to sit back somewhere, back here, and have feet touching the floor, but they also need to be out of range of the spinner, which is going to be very, very important because we don't want to be hitting ourselves every time we're spinning the weapon up. It's now just dawning on me exactly how massive this spinner is going to be. It is looking crazy. This is our carbon fiber tube that we're going to be using. And looking at this, I'm actually now thinking that maybe I do bring these motors in a little bit, because what I'm thinking is that as they currently stand, there's just going to need to be a lot of tube between here and here, and a lot of tube kind of up, and then a lot of aluminium angle or aluminium bar up here to actually kind of hold the whole weapon system in place. So it'd be nicer for everything to be a little bit more compact in, which again is part of the reason of doing this, is I would quite like the idea of quite a wide robot, but maybe we're going to borrow a little bit from the current version of Mammoth and have outward sticking prongs to get the kind of job done, which means that once again what we're going to do is we're going to change one side and then just mirror all of our changes over. And I think what I want, yeah, actually we're going to go about there. Basically, what I want is I want to still have enough space to have all the wiring and everything without having to worry about the weapon hitting things. Now, of course, haven't designed the weapon up yet, but we've only really got a placeholder in here, which is 20mm wide, which isn't a huge amount of space to put the weapon into. It hopefully will be narrower than that. I'm hoping for about 10mm wide at the tooth, but yeah, it's still a good idea to kind of keep a little bit of space around the outside edge of it. So now we have our new robot size, which actually is getting a lot smaller, as you can see. It is just inside the old footprint of Run For It, so I guess that's not too bad on the grand scheme of things. It is interesting though that we're actually going to need to do something a little bit funky here, is because we want to brace. We want to be able to brace between this motor and this motor with our aluminium or with our carbon fiber tube. It's going to get hit by the spinner. Look at that right there, which, I mean, I can do something about that. I can make notches in this tube because of course I can. That's just part of doing combat robot stuff. We don't want to do too much cutting out of this tube, because the more we cut out, the weaker it's going to be, which will kind of lead to a bit of flexing and folding on the design. But we do still have the actual weapon axle to hold everything together, and of course where the electronics sit, they are going to be cross-braced as well. So it's going to be a little bit of extra stuff that is going to help out here, but we still kind of want to make sure that we can actually do this properly. So we're going to bring this out a little bit. We also need to bring it up actually right there, which means that it's still going to need some stuff cut out of it. In fact, it's going to need a lot cut out of it, and only this bottom corner down here is going to be available to actually strengthen the whole piece, which might not be enough. Okay, so some thinking has happened, and it is time for a new plan. And this, by the way, is why you normally don't see this process. It's a bit messy and muddled, and things change on the fly very rapidly. So I normally try to have all of the CADing stuff done and out of the way before getting into a video, just because I don't think that this stuff is particularly useful to a lot of people, because it really is a lot of the time just me being like, oh, okay, this is not working. We're just going to completely redo and re-alter the design. So the weapon axle is going to go through this carbon fiber tube, which is good. Will give us a little bit of extra stability and support on that. And now what we're going to do is we're going to move back the entire drive pod so that it is going to connect behind the current or the upright. So just like this, you can now see there's a little bit of a gap here, which we need to add some geometry in here to fill all of that stuff up. But that also means that our backing piece here can now move back a decent way, probably about there, which is better. It's still not good. It's still not great. We could do a lot better with this, but a nice piece of right angle carbon fiber is actually going to hold this chassis together. In fact, what I might even do for this entire back section is cut it so that it is just this section that's not going to get hit by the weapon, and this bottom section. Just make a little L out of it and do that. But we'll worry about that later, because that's going to be in a future video, cutting all the parts for this and getting it working. So after staring at this and at Mammoth for quite a while, what I realized is that this tube is just not striking the right feeling for this design for me. And by that, I mean, I like it for the uprights. I think it's a solid idea for the uprights, but for the cross bracing and for the section that goes back and holds the electronics, which I can already see in my mind's eye is going to be horrible and just massive and bulky and look bad based on what we've got here. It's because this tube is too big. At 15 millimeters outer area or outer surfaces, it's big compared to everything else. So I am going to try instead to use carbon fiber rod. The problem is I don't have that carbon fiber rod, so I'm going to be ordering it literally right now and hope that it gets in time for this video or next video to go out, because I don't know. Maybe it will, maybe it won't. Been looking back at the footage and there is a lot of it. This is part of the reason why I don't do this on camera a lot. It's a long drawn out process, which there's just a lot of steps and a lot of things going on. So we're going to speed weed through the rest of this. It doesn't actually look like we're too far into the design, but I feel like we're fairly close to the end here actually. So I'm just going to speed weed through the rest of this. So this took a considerable amount more time than expected. Let me give you the grand tour, as it were. This here is Mini Mammoth. So we have a spinner up the front, or a lifter spinner up the front. At the moment, whoops, that's not what I wanted to do. Don't do that. We spin this way. Wow! So this is too fast. It should be spinning less than this, but whatever. Yeah. So that's the spinner currently. We do have a motor mounted up the top here. There's probably not enough space here between here and here for the gearing system that I want to do, because I want to run this on a N20 50-to-1 gear motor. It's what I have available to me. And I need a little bit more space. I kind of want to do a 2-to-1 or a 3-to-1 gear reduction for the weapon, just so it's got enough torque to hoist a robot round. Not that I think a 50-to-1 doesn't, I just think it would be better with a little bit of a gap there. Anyhow, we've also got HDPE front armor. We've got nice big panels at the moment. Obviously, these are not quite indicative because, yeah, they stop flat. I am going to run acetate on them, or I am going to cut them at an angle to actually kind of sit more flush to the floor. The whole point of this is that with the weapon mount and the weapon, like this way over the wheels, the whole robot should rest on the front armor and on these, and the wheelie bars back here are literally just that, there to stop the robot from wheeling over backwards when we take off. And also see there is 3 different types of carbon fiber in here. We've got our big thick rectangular carbon fiber for the uprights. We've got a carbon fiber rod across the back, which will be glued and probably zip tied in place to hold the wheels at the right distance apart. And then we've got these guys up here, which hold our electronics box in place. Although, thinking about it, I probably don't even need to do this. I could probably almost just mount the electronics box out the back here. However, we are trying to do a Mammoth design, and this is a good idea for a Mammoth design. I will print a concept of this box soon, and basically make sure that it fits all the electronics, because if it's bigger than I need, then I will shrink this box down, which will actually mean that I'll be able to shrink the whole robot in a little bit, because at the moment it is actually a little bit wide, although I guess that's not a huge deal in the grand scheme of things. These little off-run points at the back here are going to be screwed and glued maybe, but mostly just screwed into the electronics box, and they'll be made out of something flexible so that, yeah, if they get hit, whatever, doesn't matter. It shouldn't be too much of a problem on those. Anyway, that is probably going to be it for this video. This is Mini Mammoth in its current configuration. There is most likely going to be a bunch of changes to this before it is ready for combat, because printing the first round of parts, trying to get everything sorted and together, is probably going to reveal a few flaws in this design. I'm not going to doubt that at all. This design is probably quite flawed in a lot of respects, but that's fine. We'll deal with those when we get there. Anyway, that is going to be it for this video. I hope you guys enjoyed that one, and I will see you in the next video.